Introduction to Dependency Inversion Principle. Introduction. Hello, everyone, to today's lecture on the Dependency Inversion Principle. It is commonly referred to as DIP. This principle is one of the 5 solid principles of object-oriented design. So our goal today is understand what DIP is, why it's important, and how we can apply it to create more maintainable and flexible software design. Objectives, by the end of this lecture, you should be able to understand the concept of and importance of the dependency inversion principle, identify high-level and low-level modules in a software design, and apply the DIP to decouple software components and recognize the benefits and potential drawbacks of using DIP. What is the dependency inversion principle? The dependency inversion principle states 2 key points. High-level modules should not depend on low-level modules, and both should depend on abstractions. And abstractions should not depend on details. Details should depend on abstractions. Essentially, DIP encourages us to reverse the typical direction of dependency in software design. In order to fully understand DIP, we need to distinguish between high-level and low-level modules. First, high-level modules contain the complex logic and some of the decisions that drive the application's functionality. Low-level modules perform the basic detailed operations such as data access or file management. Abstractions like interfaces or abstract classes define the contracts that both high-level and low-level modules adhere to, thus promoting a decoupled architecture. Why is DIP important? DIP is important for several reasons. Decoupling, flexibility, testability. So first, decoupling, it reduces tight coupling between modules, making the system easier to maintain and extend. Flexibility allows us to change one part of the system without affecting other parts, thus making the system more adaptable to change. Testability, by depending on abstractions, we can more easily test individual components in isolation using mock implementations. Traditional dependency problem. So in traditional designs, high-level modules often depend directly on low-level modules, and it leads to several issues. Rigidity. The system becomes difficult to change because of intertwined dependencies. Fragility. Changes in low-level modules can break high-level module functionality. Immobility. It becomes difficult to reuse parts of the system in other contexts because of tight coupling. Applying the DIP. In order to apply the dependency inversion principle, you want to follow these steps. First, you want to identify the dependencies between your high-level and low-level modules, and you want to introduce abstractions in the form of interfaces or abstract classes to define the required behaviors, and you want to refactor both high-level and low-level modules to depend on these abstractions rather than on each other directly. Example, so let's look at an example of a design where the high-level module depends directly on a low-level module. We have a file logger class and a user service class, and file logger class has a log method, which opens a log file, and user service class has a constructor, which sets logger, self-logger as file logger, and it has create user method, which calls log method. So we can see that user class directly depends on the file logger class. So if you were to refactor the code to apply the dependency inversion principle, you can see that we have a class logger that has log method, and we have file logger that is subclass of this logger, and we have another high-level module, user service class, which has init method, which is constructor, and create user. And we can see that file logger is assigned by, we are calling constructor file logger and assigning it to file logger, and then we're calling user service and passing file logger, and then we're calling user create user. So in this refactored design, we can see that the user service class depends on the logger interface, and the file logger class implements this interface. So this decouples the high-level user service from the low-level file logger. Benefits of DIP. So applying the dependency inversion principle brings several benefits. Easier maintenance, because changes in low-level modules don't affect high-level modules as long as they adhere to the same abstraction. Enhanced reusability. You can reuse modules across different contexts and projects by simply swapping out implementations of abstractions. Improved testability. So high-level modules can be tested with mock implementations of abstractions, thus making unit tests more isolated and reliable. Potential drawbacks. So we saw that DIP offers many benefits. There are potential drawbacks to be aware of. First is increased complexity. So introducing interfaces and abstractions can add to the system's complexity. Over-engineering, so applying DIP, if you apply them prematurely or unnecessarily, it can lead to an over-engineered solution that is more complicated than needed for the given problem. Conclusion. So the dependency inversion principle is a powerful design principle that promotes decoupling and modularity in software system by making sure that high-level modules depend on abstractions rather than low-level details. We are creating more flexible, maintainable, and testable software architecture. Thank you everyone for listening.